Login accepted.
Everyone tries to hack and start a CTF. So don't forget to become a paid member. There's a lot of benefits, like a lot of merch and stuff. This alumni mentorship, I believe, is passed already, but you still get like a lot of good stuff as well. So I do recommend signing up. There's also the RVB competition coming up. So please sign up before November 8th. And I believe it's starting November 16th. And it's going to be in person or remote. Then, yeah. So who am I? I'm Ryan. I'm a second year CIS major and I'm a intern. I was previously on the NCAE team and currently on the CPTC and CCDC team. So today we're just going to go over a quick overview of what S.C.A.R.E is and then a walkthrough of the Linux hacking week since we forgot to upload a write-up on that. So S.C.A.R.E stands for Swift Crack Attack and Root event. There's going to be two Linux machines and one Windows machine. So for the Linux side, you can kind of expect like to do recon with Nmap, anonymous enumeration, and then privilege escalation with weak passwords, insecure permissions, and SUID stuff. As for Windows, you can do recon with Nmap and netexec, and then some things to look out for would be Kerberos, Aswerpros, privilege escalation with insecure permissions and misconfigurations. You can always look back on previous weeks for Linux and Windows. Um, we have demonstration for the Windows week, I believe, on YouTube already. So if you get stuck, be sure to look at those videos to get help. And then third thing would be web apps, which is very common in Linux services. So when dealing with web apps, I recommend learning how to use Burp Suite. Again, we went over this before on Web App Hacking Week. So that video is also up there for demonstration as well. So for Linux, some common services to look out for will be SSH, which is secure shell. This allows you to log in remotely to the computer, which is very good if you're able to get credentials for a user. Another thing would be FTP, which is a file transfer protocol. This holds and transfers files between users so that people can access different files from different users. This is good for enumeration due to anonymous login and such. MySQL is a database service where it just holds a lot of information such as login credentials, employee names, etc. A lot of personal PII that can be useful in an attack. And the HTTP is just a website. Pretty sure everyone knows what a website is. So as for Windows, something you'll always see in a Windows Nmap scan would be Kerberos, SMB, and LDAP. So Kerberos and LDAP are typically used for authentication and usually used for attacks such as Aswerpros and Kerberosing. As for SMB, SMB is basically like the Windows equivalent of FTP, but is also used for other weird authentication for Windows as well. WinRM and RDP are forms of login. So WinRM, it's kind of like the Windows equivalent of SSH, where you get a terminal shell when you log in with a user's password or hash. As for RDP, it's a graphical login where you can basically get a full desktop interface on the computer rather than a simple terminal as you would with SSH or WinRM. And those are just the basic services to go over. As for the prizes for S.C.A.R.E, there's going to be a $25 gift card for first place, $20 for second place, and $15 for third place. These gift cards can be whatever you want, I believe. And along with those gift cards, there's going to be coins, kind of similar to the ones from Search and Deploy if you were there. All right, now for Linux hacking, we're just going to go over a quick walkthrough of what it how to actually like complete it. So can everyone see my screen on this on Zoom? Cool. All right, so first thing we start off with is just a simple Nmap scan. So we already know that the IP addresses that we're targeting is 192.168.1.131 and 132. So, so as the Nmap scans reveals that 132 has SSH and this web app open. So you can tell it's a web app just because it has the HTTP and the 200 response code. So that's going to be Linux 2, first of all. And then Linux 1, it did not show up for some reason. Oh, I spelled it wrong. Okay, so for Linux 1, we see that there's ProFTPD, which is a vulnerable version, just 1.3.5. This is something that you'll know eventually as you just keep doing Linux hacking. But you can also look up service version numbers that may be vulnerable. So we'll go over that in a bit. But we also have SSH, HTTP, and MySQL. So if we look from the HTTP scan, we see that this directory called creds. When we developed this, it's technically not supposed to be there, but it's whatever. So if we see in this directory that we have a user called R. Jesperson, and then for password is orbital1. So this is going to be like the easy way in to get user access to Linux 1. So what we can do now is just do SSH our Jesperson and then just input our password. And now we have shell access to our user. So the first thing I typically do when I have SSH credentials is try to see if they have sudo privileges over anything. So we can check that by doing sudo-l for list. As you can see, we have sudo privileges over this script over here. So if we go to slash home, actually, Django. So if we go to this directory and cat it out, or list it out, we see that this script is owned by Jay Jangles and is owned by the group intern, but we don't have the intern group, as you can see here. So because we don't have the interns group or Jay Jangles, we cannot access dismissal code.sh. But this will be used for a different exploit instead. But to go on a little bit simpler path, what we can do is just get the use linpiece. What the okay. So we can just use linpiece to help enumerate our machine. So if you run this command, which you actually have to install yourself, you see that we have the linpiece.sh script. So if we go to this directory, we can make a Python 3 web server, which is kind of just a really bad web server. And we can transfer this file to the target machine that we owned. All right, so we already installed linpiece on here, but as you can see, we use wget to grab the linpiece file from our web server that we created through Python. So if we execute this script, we will get we'll get a lot of output, but it's really useful in trying to enumerate what kind of vulnerabilities you have. So when using linpiece, the main thing you want to look for is this yellow highlight. If it's a yellow highlight, it's most likely going to be exploitable if you just look hard enough. Red, it says you should look at it, but a lot of the times it's useless. But they're still good to look at just in case, because linpiece doesn't catch everything. So most of the times you'll have to look for things yourself. So just let that run. All right, while that's going to run, we're just going to look at the alternative way to get into the machine. And that's going to be through the mod copy exploit, which takes advantage of Pro FTPD 1.3.5. So if we look in our browser, we just search up Pro FTPD 1.3.5, and we'll most likely find an exploit on either GitHub or some other place, maybe like exploitdb. So right now we just downloaded the script from GitHub, and when we try to run it, we see that we get an error, and it just shows how do we use the exploit. So to use this exploit, we're going to use the following flags: dash dash host to specify our target, dash dash port to specify the FTP port, I believe, and then dash dash path, which would be the writable path within the website that is running on there as well. So to take advantage of mod copy, there has to be both a website that is writable and Pro FTPD 1.3.5. So now that exploit works, we see that the target has been exploited and the shell can be accessed at this directory. And if we look back at the code really quick, we can try to understand what the code is doing. So within this backdoor .php directory is using the parameter cmd to run a script command. So what this exploit basically does is it uploads a script called backdoor.php and allows you to interact with the system with the cmd parameter that you can then modify with whatever command you want. So in this example, it would be who am I? So as you can see, we ran this command who am I, and we see that we are the www.data user. So now what we can do is try to spawn a reverse shell. There are multiple ways you can do this, either through um, base64 encoding a script, or my preferred way is just uploading a reverse shell file itself. This is just easier to use and just more consistent in my opinion. All right, so what we just did now was we created a reverse shell through this generator website, and then we put it into a file called rev.sh, and then we made that Python web server again. And we can see that this is successful due to the 200 code and the get requests. And we see that get request is from 192.168.1.131. So assuming that the shell is placed in a writable directory, we're just going to change the permission so that it has executable on that script. That way we can simply just run the command. And as you can see, we have a reverse shell on the machine now. And if we do who am I, we see that we're dash data. There's multiple ways you can go about this exploiting after this. Um, we'll go over that in a bit. But if we check if this is done, it should be. There's a lot of output, but we're just going to skim through it to see if there's any yellows really quick. Okay, so there is this yellow right here, which means, so it says you can write SUID file slash user slash bin slash bruh. So that means you can either write over it or what the intended fold was path injection. So if we try to simply do path injection, what we can do is essentially make our own malicious code that will be executed before the actual command is run. Let's see. Okay, yeah. So if we cat out this binary, we see that base64 is running with a relative path, meaning that it is vulnerable, most likely vulnerable to path injection. So what this basically means is since this Bra binary is owned by the root user, is and has the SUID bit, it means that this anyone who executes this binary is going to run it as root. But since this command is running base64 with a relative path, that means we can essentially create our own binary that will run that will ex so this binary will execute our own malicious base64 binary that we create rather than the actual one that it should be running. And since it's running it as root, we can we can essentially make our own shell with the slash bin slash bash command, which I'll demonstrate right now. Okay, so as we can see here, we are now root. So because root owns just to repeat like what's happened, so because the root user owns the bra binary and has the SUID bit, um, it's executing the base64 command with a relative path as root. But since we put our malicious code in front of the base64 path, we see that base64 is now our malicious base64 is ran first instead of the real one, which would be like in user slash bin slash base64, for example. So since it's running our malicious code and is running bin bash, which spawns a shell, we're going to spawn a root shell with our code, essentially. It's a little bit difficult to explain, but that's kind of what's going on. So now that we have the root user, we can try getting the flag, which is located in the slash op directory. So this is a launch nuke.sh. The typical way to go about this would be you get the code from JJangle's script, and then you input it to the launch nuke. But for simplicity, we just cat it out. And you see that we have the flag Marine Monopolies. Yeah, and then we're going to be using these credentials later for Linux too. So if you remember from our Nmap scan, Linux 2 was running a web app on port 3000. And using the credentials that we just gained, we can just log in as admin user. Now, some of the first things that you should look for in a web app would be service versions. Service versions are oftentimes vulnerable, especially if like old or outdated, like ProFTPD. So a good place to start looking would be the three dots in the top right. You just go to About, and we see that it's SQL version 6.10.0. So using this service version, we can look for exploits for that version. A good starting point would be the NIST exploits. This shows just really briefly like what the exploit does, but sometimes they also provide exploits to the proof of concepts. And for this example, the proof of concept would be through here. So in this blog, it shows you how to set up the environment, which I copied, and then the exploit itself. So if we follow these steps and um, use the same code, we can eventually create a reverse shell. Now, not all exploits lead to a reverse shell, but that is your end goal of any type of exploit, to try to get some kind of shell onto the machine. So right here, we're just making a file called test. Wait, did I spell it right? Probably right. And so we're just trying to see if we can actually execute code on this machine. Using wget and making a Python web server is generally a good way to test something. Other ways could be through ping or ls, who am I. Simple commands like that is basically the way you want to start testing for these remote code execution. So if we look back, we see that we get a 200 code and that we're getting a successful connection. So this means that we can successfully upload our own shell and create a reverse shell, similar to before with the mod copy exploit. Okay, so now we should have a connection. Nope, guess not. Let's see. Okay, so yeah, now we have a connection. So as you can see, we're the root user, but since this web app is running on a Docker container, which is noted by this little random hash over here, we we know that we are in this little container, but we have to escape it somehow. So when you're the root user and you're in like a Docker container, for example, a good place to look for would be the shadow file. So within the shadow file, you'll most likely find like hashes that could be crackable. Sometimes it is, sometimes it's not. You just have to go around and check, see if you can. So there's multiple ways to go around cracking the hash on a Unix-based systems. The way I like to use is just with John the Ripper. So when you're using John the Ripper, you have to get both the shadow hash and the password hash. So what this basically does is using unshadowed to kind of combine both the password and shadow hashes so that it's readable and crackable by John the Ripper. So to use John the Ripper itself, we just use John, the file name we want to crack, and then the word list we want to use to brute force this attack. Oh, we already cracked it before. So it will go on for a while, but once you actually do crack it, bruh. All right, well, the password is QWERTY, QWERTY 123. But yeah, you will display like a lot of code and you will see like a crack with orange text. That's how you would know that you actually get the password. So because we got this password, why don't we try SSHing with the password we would have gotten? So we see that the password works, and then again we want to check pseudo privileges. And as you can see that JChen cannot run pseudo privileges on this machine. So we have to find alternative ways. Typically you would run linps again, but since we're kind of short on time, we're just going to do this faster way. So with this command, we're basically just finding what kind of SUID bits or binaries can we execute. And the most unique one would be the base 64. So with the base 64, if we go to GTFO bins, which is a repository of all like binaries that you can exploit. If you go to base 64, we see that it allows you to read files that you're not allowed to look at typically. So this can mean things like the shadow file. So if we just follow these basic steps down here, we see that we have to specify the file we want to read, and then just this command over here. And as you can see, we have this hash. So we repeat the same thing for previously where we just cracked the shadow hash. Um, we'll eventually get the password called Bronco1 because why not? And just to further explain this base64 SUID. So because this binary is running as root, we can read the file. We can read and encode files, and the file that we specified is /etc/password, and we put the output into another base64 command where we decode it. And now since we can encrypt it and decode it, we can eventually get the whole output of the file that we can't originally read. So as you can see now that we have this file that we can now run with pseudo privileges. It's /op/acl.sh. So if we cat it out, uh, we see this line of code. So especially in pen testing, you're going to have to know some kind of code, especially Bash or Python. But to simply explain, if the target is not within J Solomon's home directory and it's not and it's using like a relative path to go to a previous directory, it will output access denied. If not, then it will allow the script to run and then essentially allow you to change the ACL permissions of the file. So ACL and chmod are used to change permissions of files, but they're a bit different. ACL allows you to change things that typically you wouldn't. I'm not really sure how ACL and chmod are different entirely, but I just know that ACL is a little bit more powerful than chmod. So to start, one of the things that we can modify to gain the root access would be the password file. So if we add our user to the password file and specify it as the root user ID, we can essentially make a backdoor where we log into the root user without a password. A little bit hard to explain, but you will see really soon. So with symlinks, you're basically making a redirect from the Swift file to the /etc/password file. So any changes you make to the Swift file, you'll have access to, they will be reflected onto the etc password file. Already created. All right, well, I already created a symlink before as a test, but typically you would see an error over here saying that it's not writable. Uh, okay, yeah, it's writable right now. But typically you wouldn't have write access over it. So what we can do then would be to run the script so that we do have write access over it. All right, so if we look back at our entry um, with the Bro2 user, we see that right here we made this new user called Bro, and then because there's no X between these two semicolons, that's specifying that there's no password set for this user. And then with these user and group IDs, we're specifying them as 0, which is the same as root up here. So because it has the same user ID and group ID, we're going to be impersonating the root user when this person logs in. And then I don't really think this part matters, but this is going to be the home directory of the user, and this is going to be the shell that we're going to spawn with the /bin/bash, which is the same thing that we use for the path injection. So then if we switch user to the Bro2 user, we see that we become root. And then we go to the home directory and cat the notice.txt, we see that we get the flag, what is a kilometer? But yeah, that's basically the environment. There are a little bit more complex vulnerabilities, but we're a bit lacking of time. So yeah. So just going back to the S.C.A.R.E competition. Let's see. So this is going to be the briefing packet. I think we're still patching some bugs on the environment, so don't deploy yet until maybe, I don't know, 6 p.m. Um, yeah, so this is the link to the briefing packet if you guys want to read over it. There's some funny lore in there. I recommend looking at it. Um, and if you need like reference from previous weeks, we also have links to the Linux hacking and the Active Directory hacking as well. So, yeah, that's basically it.